Alright, so today we're going to go over a little bit of an intro to assemblies using the part studio that we created last time. So this is the part for the 1 degree of freedom intake that we were talking about during class last week. I'm going to use those parts to show some ways to create an assembly here. So the first thing I'm going to do is I'm going to insert the parts from main sketch is the place where I design all the parts, so I can open that guy up. From here I see the 3 parts that I generated. I can just click those parts here. I'm just going to click them, and I'm not going to move my mouse around the studio to like try to drop it in a specific location. I'm just going to click the parts and then press the green check mark. That way what it does is it drops in the parts exactly where I designed it in the main sketch. And because I designed them in the places I want them to exist on the actual robot, this plate and this plate over here are exactly where I want them to be. So there's a couple of ways to get this to kind of stay right here, like kind of a cheater way to get your assembly going. If you know that these parts are all, at least this mounting plate is where it's supposed to be, I can make a group and click the drivetrain and that side part. And when it's in a group, they all kind of stick together. And because the original mate was fixed and doesn't move, because this is grouped with it, it's also fixed and it doesn't move without me having to create an actual mate to it. But we're not going to do that. We're going to actually use mates today. So mates are different ways that you can constrain parts to other parts. They use what's called mate connectors to give you kind of local coordinate systems and to kind of match up in a way where it defines the specific degrees of freedom you want or don't want between 2 parts. So for example, if I click this mate connector tool here and I just highlight a feature, it'll pop up with this orange disk, and you see this orange disk has a set of axes, a blue, red, and green. And in the convention of Onshape, blue is the z-axis, so the z-axis is normal to the little disk that's getting populated inside that feature, and then the red and the y-axis show you the directions of the local x and local y. And so what I'm going to do here is in order to make this part stick to this part without it moving at all, so that's 0 degrees of freedom, I'm going to use a fasten mate. So a fasten mate, we can see here, the hotkey is M, is a mate that makes 2 things attached to each other with no degrees of freedom allowed to move. So I can see, I'm trying to see where that hole is. Okay, so these are the 2 holes that I'm looking to mate. So I'm going to press the fasten mate. I'm going to move this part off a little bit so I can see the hole better. I'm going to select here so that there's that local axis pops up, that local coordinate system, and then I want it to have the same origin as the local coordinate system at the surface of this plate. So if I click here, you see that the surface to surface touches, I solve it, it pops it in the right spot, and I can press OK, good. So that's the actual axis I want it to be on. So just to kind of give you an explanation of why that specific face of the intake, let's say I select this back face. It's the same Z. It's the same z-axis. The z-axes are aligned with each other, but the x and y's are not. So if I click this one, what it'll do is it'll actually move the part. If I solve it, it'll move the part inside one of another. Because remember, the mate connector is trying to make these 2 coordinate systems, kind of the origins sit right on top of each other. So we don't want that in this case. We want the other face, because that is the face that we actually want to be touching the drivetrain. So that's fasten mate, 0 degrees of freedom, fully constrained. I could also use fasten mate with an offset in order to get me a specific distance. So this plate and this plate are designed to be 1 inch apart. So I can use that fasten mate hotkey M. I want that circle to touch that circle, but I want it to be 1 inch away. And usually to create separation like this, you do negative. So -1, sorry, I did that fast. I click this offset checkbox here, and then in the z-axis, so in the z-axis or z direction of my mate connectors, I want it to move -1 inches. So this is z of your mate connector, not z of your assembly, right? So we're looking at this local coordinate system and moving in the z direction here. All right. So that is the first mate is fasten mate. Next mate, so I'm gonna just move this guy over here, still using a fasten mate, to drop in the second plate. Oh, and I did that in the wrong location. So I selected the wrong hole on the other side. So you can see that it's about a hole off. It's about a 1/2 inch forward of the original plate. So what I could do here is I could do an offset here. And if I look at the local coordinate system, it's in the x-axis. So I'm going to add 0.5 inches to that coordinate system. And then it moves it right in line. So there are two parts. If I click on the right side, I only see one of them, which means that they're perfectly aligned with each other. So that's good. And then I can select these two plates. I see these plates are 23 inches apart. So now we're going to go into like adding parts from MKCAD into our assembly. So 23 is the distance from this plate to this plate. And I want to put a shaft between those two plates. So I'm going to go here to hex. I'm going to look for a 1 inch hex, or 1/2 inch hex shaft. And click that. I'm going to drop in my effective length here. Thunder hex is good. And then I'm going to change the retention to bolt and washer. And then I'm going to put don't include. So what I'm actually going to do is when I fully assemble this, I'm actually going to put a bolt and washer from the outside of this plate into the end of the shaft. So the shaft is going to be tapped with threads. But if I use the bolt and washer retention here, what it's going to do is going to put the bolt and washer right at the ends of the shafts, which is not what I want because it's going to have this 1/4 inch of plate in between it. So I'm going to insert that shaft. And then I'm going to use the fasten mate again. I'm going to click the very end of the shaft, which is that mate connector here. And then I'm going to, let's go on this side. I'm going to select this interior hole. It's going to drop in the shaft. I'm going to press OK. So now I'm going to move this guy here. It has a shaft going all the way across the tube. I could also use MKCAD to drop in. We have a 1 inch space in between here. So I'm going to look for a spacer. That is for a number 10. So this, you can tell it's for a number 10 because the ID is 0.196. So that is for a number 10, 1 inch difference. Insert. And so now it's going to drop in the part in the middle of my part studio. I use my fasten mate again. I'm going to fasten it to, let's go ahead and go to this location here. And then see how it goes. Sometimes the mate connectors like will flip, will not be the direction that you want. Even though it's the right connection point, it's not in the right direction. So I can flip the primary axis here and it'll move that part around. Okay. And then, so for this here, I realize I'm gonna have a gear here. So this top hole does not have the same hole pattern as this because we don't want we want to put a bearing shaft and gear here, so we can't have a standoff or else that would interfere with the gear that's moving around in here. So what I'm going to do to create the rest of this is I'm actually going to use a circular pattern. Instead of adding another spacer and repeating with fasten mates, I can have this one part here, circular pattern. It's going to ask for the axis of the pattern, and the axis is going to be the axis that goes through any one of these circles. So I can click this circle here, and it will, and instead of 2, I'm going to put 3. It'll drop in 3 instances, or it'll have 3 instances of that initial spacer around this circle. So that is circular pattern. Then I'm going to talk about 2 more mates. Revolute mate is similar to fasten, except for it removes 1 degree of freedom in the rotational axis of Z. So if I select like this part here and then this end here, I click the whole plate. So I want to select the mate connector that's back over here on this, like on the other side of this hole. This shaft is kind of in the way. What I can do is I can press shift and then move it over here. And then when I click this axis, it will use the hole. Right now it's using the mate connector of the shaft, but you can also get the mate connector of the plate. Either one of those could work in this case. And then because there's going to be like a bearing in here and there's going to be a gear connected to the outside, I actually don't want it to be directly in line with this. What I want to do is actually offset it again by 1 inch, and it's got to be negative in this case. So one thing that I'm seeing though is if I do that, this will be interfering with each other. So I probably want to redesign this plate to give some clearance to that, or I can move this in or out, which we just want to verify is not going to mess with any of the like the gearing position. So that's fine for now. So that was revolute mate. So you can see revolute mate. I can't move it like left or right, but I can rotate it. So it's fixed in the X, Y, and Z translational location. So the origin is where I want it to be, but the the X and Y axes are locked, and the Z axis is allowed to rotate. Right, and then so this is different than like a cylindrical mate. So if I do, let's add another one of these plates here. There's another mate that's pretty similar, cylindrical mate, right? And you can see in the description or the icon here that has an arrow that shows rotation, and that has another arrow that goes up and down, whereas the revolute mate icon just has a rotation. So what this is telling you is that it's actually allowing for another degree of freedom. So if I select this hole here and this hole here, it'll move it similar to the fasten mate would. So I'm just going to accept that. And so it'll rotate, but it also can translate. So it gives you rotation and it gives you translation in the Z-axis only. So you got one axis of rotation, one axis of translation for a cylindrical mate. So those are often useful if you want to have two parts that the axis is the same, but it's allowed to move. There are some ways that you can use some of these like relations to like make some of that useful. For things like this, what it's useful for. So let's say I already have this intake plate in here. And let me copy, paste again. I'm going to use a revolute mate instead. So I'm going to go here, select this face here. I'm going to do the same thing. I'm going to do offset of 1 inch here. Cool. So now this is exactly the same as the other side here. Now this is fixed in its X, Y, and Z location, like the origin of the mate connector that we placed here. That's not going to allow to move. So if I want these two things to be lined up, so if I look to the side, these things aren't lined up, right? If I try to do something like a fasten mate between these two to get the holes to line up, and then even if I try to give it like an offset, so these things are, let's see, these things are 20.5 inches apart. If I did a fasten mate here, let's do fastened, and I know these things want to be 20.5 inches apart, so I give it that negative 20.5 inches. Oh, that works. So that's one way to do it, but that you have to do an offset, which is not as intuitive. Like you have to do some measurement and figure out some distance. I wonder why it didn't over constrain. Anyways, another way you can get those to line up is if you just use a cylindrical mate and then select like this bottom circle here and this bottom circle here. So now these two parts are allowed to, the axis has to be the same, but the Z direction of them doesn't have to be defined. So for some reason, let's say if I want to move, this guy is actually interfering with something, so I want to move it out a little bit. If I take that revolute mate and I change the offset to say -2, and it moves inward, right? Your first mate doesn't actually, your cylindrical mate won't break because it's allowed to have that translation degree of freedom. If I do Control Z and I add in that fasten mate again, so fasten mate, and then offset -20.5. So it puts it right there. If I do the same thing and I go here and I say, I actually want this to be -2 inches, it's gonna break stuff because now what you're calling here as a 2-inch is conflicting with the 20.5-inch distance you're trying to impose here, along with the distance that you're trying to impose here. You see how it actually is now touching because it's enforcing the 20.5 distance and it's breaking that 1-inch fasten mate that we started up here. So that's why the cylindrical mate is a little better use case in this scenario, because it allows for that translation of this part. So I'm actually, what I could do here is instead of having to delete this mate and then change it to cylindrical, I can go in here and I can change this to, oh, this is the right mate. This is the wrong mate. Did I already break it? Ah, it's already broken. Okay. So I'm just going to put it in cylindrical mate. There you go. So now it's fixed. What I was going to mention before is that you can actually change mates in the mate tool window. So let's say I didn't want that to be cylindrical mate. I wanted that to be the fasten mate. I can just select this here and change it to a fasten mate if I wanted to. So that would work. So those are different ways you could change mates. Other parts that we would want here in this assembly, just to show you a little bit more of MKCAD, is I can look for bearings. So if in the bearing section, these are for a hex. So this is a 1/2-inch hex. So I'm looking for a bearing that has a 1/2-inch hex. I can mate connector those with a fasten mate. I want this flange bottom section to touch the outer side of this plate. So now that gets mated. So you can see the bearing is sitting inside that plate now. Copy, paste this, same thing. I want this lower section of the bearing body to touch this outer section, and it's flipped the direction that I want, so I want to flip that. Cool. And then I'll just show the inserting of a motor as well. We'll do a motor and a gear. So I can do like a Neo motor, Neo brushless motor here. Insert. I want the face of the motor to contact the face of the motor mount. Flip the direction, and we can see here that the motor itself has like this boss feature on it, like a little cylinder popping off the face of the motor, and it's interfering with the diameter of that plate. So I'm actually going to offset this guy by a couple things. I can't make this hole bigger to accommodate this boss because of this bearing hole. So I'm going to move this back by 1/4 of an inch. You can see it there. So then I can add in a spacer here like we added in the spacers from here. And let's go ahead and do the 70-tooth gear that interfaces this with the shaft below. So because this is a dead axle setup, I actually want the gear that has a hole in the middle. So let me check this guy over here. Or like a large hole, so not a hex. So you see this has this funny shaped hole on the inside. This spline here allows you to get a few different kinds of products to interface with this part. We really want to use this with a bearing. So actually this bearing over here is not in the right spot. It's not going to be in this plate. It's going to be in that gear. So what I'm going to do is I'm going to right click this guy. I'm going to say show mates. It's going to show the mate that is applied to this bearing in this plate. I double click here. It shows me it's fastened 7. I'm going to open that up, and I'm actually going to say I don't want this connected to the main intake plate main connector. I'm going to X that, and I want it to be in the center of this guy here. So for shapes like this, it's kind of hard to click the center. So what you want to do is you want to highlight the face, and that should give you the center of that face. But it can still move depending if you're close to another feature. So something that I do to like kind of guarantee that I can find it is go to the face and I select shift. I go to the center, and then shift allows all the face kind of points that could potentially be a mate connector to remain open, and it's not going to like try to smart find out which one is right next to you. So I can select the middle one here, and it puts the bearing right in the middle. And then same thing on the other side. I'm going to do another fasten mate. I'm going to select the center of this back face, and then I'm going to select this face here. Cool. So now that gear's on there. Now you can see the holes that are in this plate are actually designed so that they're supposed to interface with the holes here. So we could actually do that revolute plus cylindrical mate trick here as well. So I'm going to go to that fasten 10, and I'm going to change this fasten 10 to a revolute. So now this gear can spin in the context of that plate. And now what I want to do is I want to use a cylindrical mate to make this hole line up with this outer hole here. Wrong direction. There we go. So now, if I look at it sideways, this hole is lined up, and this hole is lined up. Did I select the wrong one? Might have selected the wrong one. Oh yeah, I broke some mates. So let's delete that guy. Let's try that again. Let's bring the intake all the way in a position that we want it to be in. Okay. There we go. So those are the holes we want to line up. So let's try that again. Cylindrical mate. I want this hole to line up with this feature here. There we go. So no mates are broken. Nothing's red over here. I can see my holes pass through. So that means I can actually fasten this stuff together. And we can see that we have the parts are because the gear bearing assembly has a revolute mate to the center of the spinning part of this intake plate, and the cylindrical mate makes sure that these two holes are sharing an axis. When I rotate this, it actually acts kind of like a fasten mate. Those two things will stay fixed together. So as we use the revolution mate from the main intake plate, we use the revolute and cylindrical here as kind of like a fastened for some circular features. So that's a way that you can use assemblies to put together robot parts.